Hi, this is Mr. Lemansky speaking, and this is Lesson 4.1. We're on page 206. We're starting Chapter 4. This lesson's called Plotting Points in a Coordinate Plane, but there's going to be a second thing I'm going to cover that's not in our book as part of this lesson. We're going to also interpret graphs of functions. I'm going to put that in here too. I have a lot of vocabulary to cover, but I don't want to make this video long, so I'm going to get right into it right now. Let's talk about plotting points in a coordinate plane. And there's some important vocabulary, and I think some of this will be review for you as we go through it. There are four quadrants in a coordinate plane. This picture I'm sure you've seen many times. We've done graphing on this sort of picture. This is called a coordinate plane. There are four quadrants in this plane, and you can see them clearly here. Quadrant 1 is in the upper right-hand corner. So quadrant 1 is right here. And then I labeled quadrant 2, which is in the upper left-hand corner, quadrant 3, lower left-hand corner, and quadrant 4, lower right-hand corner. I know that seems kind of weird because we're used to reading books and we read things from left to right. When you have quadrants, it's counterclockwise. 1, 2, 3, 4 from upper right and around. Okay? I know that seems kind of awkward, but that's how that works. Next, there's another important point here. It's called the origin. The origin is where these two lines meet. It's the point 0, 0. Pretty sure you've learned that before. We have an x-axis. I've labeled that in red clearly, and we have a y-axis, which I've labeled in yellow. So x-axis, y-axis meet at this point called the origin. That's the point 0, 0. I'm sure you've heard that vocabulary before, but I just wanted to review it with you. Let's quickly review plotting points. Very important that we can plot points correctly. I would say most of you probably have this down, but as a algebra teacher here for 8 years, I have seen students that have this confused, and if you confuse this, it's going to cause other things to be wrong. So I just want to review it to make sure. Let's look at plotting the point -3, 5. Here's what that means. We should start at the origin. The -3 means move 3 left. The +5 for y means 5 up. Now remember, maybe I should just write this in there. Remember, this is an x, y coordinate. And remember, this is the x-axis here. You can see me labeling it. And this is the y-axis. So when it says -3, that means I should go 3 left of the origin on the x-axis. And then since y is 5, I'm moving 5 up, and I should put a point right there. I'm going to get rid of the lines here. We don't draw these lines on there that I just did. I was just helping show you 3 left, 5 up would get me here. Here's another example. What about plotting the point 7, -2? 7, -2 means start at the origin, go 7 right, 2 down, and plot your point. Now again, I just drew these lines on here to show you how I got the 7, -2. You wouldn't actually do that when you're plotting points. You would just go 7 right, 2 down, plot a point. So I hope that answers any questions you might have had on plotting points. We've already plotted some points this year. Okay? Next, got to talk about some vocabulary that pertains to what I had just talked about earlier. Let me just go back. Remember, we're going to also interpret graphs of functions. Now, there's a whole list of vocabulary that we need to know for that. Okay? So let's start here. First of all, and maybe I should take let me get a different color pen real quick, because I'm going to write on this page. Okay, so then I think I'll write maybe in yellow because that will show up nicely here. All right, so first of all, we have this term here called intercepts. Okay, and you can see that. Here's what an intercept is. There's 2 intercepts typically on graphs. And you can see here they have a graph and it's in the first quadrant only. when you have any kind of line, when it touches, where that line crosses the y-axis, that's called the y-intercept. That's an intercept. It's called the y-intercept because it crosses the y-axis. And you can see that listed here, okay? Where we intersect the y-axis, that's called the y-intercept. And you can see that right here. This line in black is going to cross the y-axis right there where I plotted in yellow. There's my y-intercept of a graph. There's a second important point a graph could cross. It's where we cross the x-axis, and of course that's called the x-intercept. So where a graph crosses the x-axis, that's called the x-intercept. And you can see on this picture that would be right here. Okay? So there's 3 vocabulary words right there. Here's one of them, intercept. An intercept is when our line crosses either the x or y axis. The y-intercept is specifically where my line crosses the y-axis, and my x-intercept is where it crosses the x-axis. So real quickly, if I just go back a page, and let me just get rid of these, and I'm going to quickly erase out, this. So if I go ahead and I was to draw something like this on my paper, just think for a minute, maybe pause the video and label what would this, and what would this be called. And I hope you're coming up with, this would be an x-intercept, this would be a y-intercept, and I would have an x-intercept here. Be good if I spell it right, x-intercept. Okay? All right, so we got 3 vocabulary words there. Now here's the next thing. Let's talk about functions that are linear and functions that are nonlinear. How can you tell if a function is linear or nonlinear? Very easy, okay? Look at the word linear. Do you see the word line? If the function creates a straight line, it's linear. So maybe I should just write that here. Linear, it means straight line. Okay? So if you look at a graph and it's a straight line graph, it means it's a linear function. I hope that answers what nonlinear would be. Okay? A graph would be nonlinear if it has a curve to it. So going back to my previous picture, this graph has a curve to it. This graph would be nonlinear for that reason. This is a nonlinear function that I just drew. Okay? So far with vocabulary, we've now had 5 words. Intercept, y-intercept, x-intercept, linear, and nonlinear. Okay? I don't think those words are hard, but they're all very important words to know. Okay, continuing on. We got some other vocabulary we have to look at. Let's talk about the term line symmetry. Line symmetry. Here would be an example, a good picture of what line symmetry is. If you have some kind of graph, and you can draw a line, a vertical line through that graph, and it makes each side of the graph match the other side exactly, that's line symmetry. It's kind of written up here. So for example, if you look at this dotted line here that I'm kind of pointing at, if this sheet of paper, we could take the right side, which I'll label R. If we folded over the dotted line, the right side would completely match the left side. This has line symmetry. I always kind of think of a mirror. The right side mirrors the left side. That means we have line symmetry for this graph. Okay? So line symmetry is another vocabulary word we need to know. Next, got several more words we have to know. Again, this lesson, a lot of it is just vocabulary. It's not actually working out math questions. It's just knowing vocabulary. Okay, so several words here. As you notice, first of all, I have a nonlinear graph in this picture. It's not a straight line. A function is positive where it lies above the x-axis. So let me take my yellow marker, and for this function here, this would be positive. This function is positive here. It's also positive here because you can notice this part of the graph is above the y-axis. Negative. Let me take a red marker. You see where below, I might have misspoke before, I meant x-axis. I might have said y-axis, and if I did, I meant x-axis. Here I'm below the x-axis, that's negative. Here I'm below the x-axis. My function is negative here. So yellow was positive. That's where I was above the x-axis. Red is negative. That's where I was below the x-axis. Again, if I misspoke earlier, I apologize. Unfortunately, I can't rewind the video to there and make it right. It's the x-axis I'm referring to. Okay? Right here, x-axis. Okay, next. A function. It's increasing where the graph goes up, and it's decreasing where the graph goes down. Now, this is super important. Maybe I should underline this in green. You have to read this from left to right, however, because I always have people ask, well, isn't this going up? No, it's not. Read it like a book. I'll take a yellow marker and trace. I'm going to work from left to right. So I'm going to start here. My graph is going down here. It's decreasing. And now when I get to here, I'll pick a different color because now my graph is increasing. And when I get to here, now my graph starts decreasing again. Okay? So you can see here, we have a decreasing graph when from left to right it's falling. It's increasing when it's rising from left to right, and it's now decreasing again here. All right, next. On a graph, you notice on this graph that we have some low points, we have some high points, and it can vary. Those points have special names. Okay, the low points or high points, the low or high function values are called the extrema. You can see that here. Okay, now these extrema have special names. These little high points at certain part of the graphs are called the relative maximums. Like you can see right here, there's a little high point on this little bump right here. That's called a relative maximum. And then this graph has a little low point right here, this little dip, and that little low point's called a relative minimum. Again, there's no work to this. Like on a quiz or test, what I would probably do is just draw a picture like this, and I'd say, okay, show me where the graph is positive, show me where it's negative, show me where it's increasing, show me where it's decreasing. Label the relative maximum and the relative minimums. Okay? Now, one last thing. End behavior. This graph, you notice how it kind of starts here and then it finishes down here. It has end behavior. Now, the end behavior. At this left end, as x is more negative, y increases. You can see this. If I go negative for x, y is increasing. Here, as x becomes more positive, y is decreasing, which they wrote. That's called end behavior. End behavior for that. So that's the vocabulary that I needed you to know. Again, set bunch of different words, all right? Just real quick, just to go through a quick sample. So like here, if you look at this question here, you can see, first of all, several things. As I look, my graph right here, all of these points on my graph here are positive. They're above the x-axis. Down here, my graph is negative. It's below the x-axis, which was vocabulary we just learned on the previous page. Okay? You erase that out, get another layer. Okay? You can see on this graph that my graph has relative maximums here. I got a little high point there. I got a little high point there. There's another relative maximum. Looks like I might have a little relative minimum right here, a little low point right here. Okay? Which you see, these are labeled actually right below here. You can see those. There's a maximum, and my minimum. Okay? Next vocabulary. Remember, my graph right here is increasing to here. Then it looks like we have a little decrease down to here. Then it looks like it's increasing up to here. And then it looks like we have another decrease there. Just using the vocabulary I've learned. And then the end behavior. The end behaviors, let's talk about that. As we move smaller for x here, y is becoming smaller. It's becoming more negative. So as x decreases, y decreases. There's the end behavior on this side. Over here, as x increases, y decreases. There's my end behavior. I think I'm going to pause the video there. I covered all the things we need to cover.